You've seen a weather map, right? With the colors for rain and sun. Well, what if I told you this is a weather map for radiation? It's real, and it was created by some citizen scientists right near the San Onofre nuclear generating station. Now, I know those bright colors look a little intense, so today we're going to break down exactly what this all means. Let's get right into it. Okay, so here's the map that's got people talking. You see all the cool blues and greens, sure, but what really jumps out are those bright, kind of angry-looking blobs of red and orange. And at first glance, yeah, it's easy to feel a little bit uneasy looking at that. So the million-dollar question is, what is this map actually telling us? All right, first things first. To really get what this map is saying, we've got to learn how to speak its language, the language of radiation. It's all about understanding the units and what these different colors really represent on the ground. The key unit you gotta know is the microsievert per hour. I know, it's a mouthful. You can just think of it as a tiny measuring cup for radiation. It tells us how much, or really the rate of exposure you're getting every single hour. It's a global standard, so it lets us compare apples to apples. So, this chart is basically our color-coded cheat sheet. The blues and greens, that's just normal, everyday background radiation. Totally expected. The purples and pinks show things are a little bit elevated. But it's those reds and oranges spiking all the way up to 65 that get labeled a significant hotspot. So what do we mean by normal? Right, so here's the thing. We are all surrounded by a tiny bit of radiation all the time. It's unavoidable. It comes from the rocks and soil under our feet, from building materials, and even from cosmic rays that are zipping down from outer space. That's what the map shows as those cool blue and green zones, just the normal, everyday hum of radiation on planet Earth. Okay, so we've established that the blue and green is normal stuff. Now, for the main event, what is the deal with those bright red and orange hotspots? Where exactly are they? Let's zoom in. This is the key question, isn't it? Especially if you're a local, if you surf those waves, you want to know, are these hotspots anywhere near the beach? Anywhere near the public? And boom. Here is the answer. The data is super clear. These high readings are not on the public beach. They are not in the water where people surf. They are located right on the plant property itself, at a very specific spot called the Independent Spent Fuel Storage Installation. Let's call it the ISFSI for short. So what in the world is an ISFSI? Well, you can basically think of it as a high-security parking lot for used nuclear fuel. The fuel is sealed away in these absolutely massive, heavily shielded concrete and steel canisters. So really, it's the one place on the whole site where you would absolutely expect to find higher but contained levels of radiation. Okay, and that brings us to the most important question of all. We know where the radiation is, we know why it's there, but is it dangerous? Let's put these numbers into a perspective we can all understand. Let's frame it in a real-world way. You're loading up your car, you're heading out to San Onofre for a dawn patrol session. Should this map make you think twice? Well, the data draws a very, very clear line in the sand. When you're on the public roads or down at the beach, the levels drop right back to normal background. It happens really fast. But if you walk right up to the fence of that storage facility, the readings are way higher. And that right there is exactly why that area is fenced off and access is restricted. Let's laser focus on that peak number from the map, 65 microsieverts per hour. It's obviously a lot higher than the background level, but what does a number like that actually mean in terms of health risk? Here's some really great perspective. If you could actually stand right in that hottest spot for a full hour, which you can't, it's a secured area, the dose you'd get would be about the same as getting 2 or 3 chest CT scans at the hospital. So yeah, it's a significant dose, but it's one you'd only get by being in a restricted area for a good chunk of time. Now, check this out. Let's imagine you spend a whole 24 hours right there in that hotspot. The dose you'd absorb would be over 1.5 millisieverts. Now compare that to the bar next to it. The official safety limit for a member of the public for an entire year is just 1 millisievert. So one day there would blow past your entire yearly limit. This just hammers home why that fence is there. So let's pull the lens back and look at the big picture here. What does all this data really tell us about the situation at San Onofre? And, just as important, about the power of regular people collecting data? This is maybe the most critical point to understand. The hotspots at San Onofre are from contained nuclear fuel. The radiation is localized, it's not spreading out into the environment.
This is a totally different universe from a nuclear accident like Fukushima, where there was an uncontrolled release of material that spread far and wide. Two very, very different things.
And this brings us back to the people who actually gathered all this data. This is a perfect example of what's called citizen science. And as one person put it, citizen science like this helps keep an eye on things. It's all about empowering the community with real information.
The real value here is that these citizen scientists can get up close and personal, taking readings that the official, stationary monitors, which are set up much further away, might not be able to capture in this detail. This kind of data just adds another layer of transparency and helps keep everyone accountable. It's a good thing.
So, to wrap it all up, what have we learned? This map does not show a public health crisis. What it does show is expected contained radiation, exactly where you'd expect to find it, inside a secure facility. And at the same time, it's a powerful demonstration of how valuable public monitoring is for verifying that everything is as it should be. And full credit for this awesome data goes to Gene Stone and Darren R. McClure. Their work is part of the larger #SaveTrestles movement, which is dedicated to protecting that beautiful and iconic coastline. Their effort gives us this incredible, detailed snapshot. And it kind of leaves you with a final thought. When it comes to our own backyards, what else should we be keeping our eyes on?